Let's look a little bit more at conditional probabilities, shall we? Well, if you notice right here, it's a little bit different situation, huh? We've got a Venn diagram with some probabilities of just A and B. You've got the probability on the outside here. Well, first of all, before we get into all this conditional probabilities, let's understand what's going on here. All right? The probability of B happening is all of this. The probability of B happening is actually 0.65, just so we're clear about that. The whole B circle would be B happening. That's the probability of B. Over here, the probability of A happening is 0.4. So we add those together. That's the whole circle right there. And then the probability of A and B happening is right there in the middle. The probability of A and B happening would be a 0.15, and the probability that neither of these things happens is a 0.1. So hopefully that gives a little bit of clarification on why this Venn diagram looks the way that it does. So we want to find these conditional probabilities. First, the probability of B given A. Well, we know conditional probabilities, the probability of both happening, A and B. Remember that word and is in there. And so the probability of A and B is 0.15. And we're going to divide that by the probability of A. Well, what is the probability of A? The probability of A, the bubble A, is 0.4. Let me get a calculator. All right, so we go 0.15 divided by 0.4, and we get 0.375. It's the probability that B happens given that A will definitely happen. Okay. Next one, the probability that A happens given B. Well, once again, it's probability of A and B. That doesn't change. That's 0.15. We divide that by the given. What is the probability that B happens? Well, probability of B happening is 0.65. Okay, read that right. It's not 0.5. Probability of B happening, anything in that B circle is 0.65. Again, we divide that 0.15 divided by 0.65, and this comes out to be about 0.231 if I round to the nearest thousandth. Next one, the probability of A given not B. Well, the probability that A and not B and A, satisfying both of those constraints, is this part of the A bubble. That is both not B and A. So the probability that both of these things happens is just 0.25. We divide that by just the probability of not B. Anything not in B. Well, that's this and this down here. The not B's is a 0.35. So we divide this. This would be 5/7, which comes out to be about 0.714. Again, if I round to the thousandth. Last one here, the probability of B given not A. Well, both of these things happening, once again, the probability of it being B and not A and B is just this region right here. That is both B and not A. So that would be 0.5 on the top, because that is both of these events happening, divided by the probability of not A. Well, not A would be that 0.5 and the 0.1. That's everything that's not A. So that is 5/6, which comes out to be about 0.833 if we round again to the nearest thousand. Okay, so that's using some Venn diagram for it. All right. Here, unique question. It says, if the probability of B is 0.7 and the probability of A given B is 0.45, determine the probability of A and B. Well, let's remember our formula. The probability of A given B equals the probability of A and B divided by the probability of B. So we divide by the given. So if we plug in everything we do have, probability of A given B is 0.45. We know the probability of B is 0.7. And the probability of A and B, we don't know. That's actually what we're looking for. We just solve for that one missing piece to get that. We're dividing by 0.7, so we're just going to multiply both sides by 0.7. And we simply multiply that together. And the probability of A and B is 0.315. Just plug in what you got. Look, you solve for what's missing. Yeah. All right. Last thing we're looking at here. Again, we've got a Venn diagram. We've got a piece of it, and they give us some information very similar to what we had before. My game plan is I'm just going to fill in everything that I can up here, given the information over there too, and then I'll look at these questions. Then I'll look at the questions. All right. So first, if the probability of B given A is 0.45 and the probability of A is 0.4, well, this is very similar to the last one we just looked at. Remember our formula? Okay, this is probability of B given A. So that's going to be the probability of A and B divided by the probability of A. Well, we know the probability of A is 0.4. The probability of B given A is 0.75. We can use this to find the probability of A and B, which is right here. Right there. That circle is the probability of A and B. So we multiply both sides by 0.4. This side by 0.4. This comes out to be 0.3. So the probability of A and B is 0.3. Well, if all of A is 0.4 and this piece is 0.3, that means this piece right here must be 0.1. And if we add those up, 0.3 plus 0.45 plus 0.1, that's 0.85, leaving us a 0.15 on the outside. So it all has to add up to 1. So the probability of A and B would be 0.3. The probability of B is 0.75. That's the whole circle over there. The probability of B union with A. Okay, union is any of A, any of B. It's that or. Well, if we add up all those things in A or B, we've got 0.85. This last one here, what is not the intersection A and B. So again, we read that right there. We read that right there. We read that as and. What is not A and B? Well, here is A and B. So not this right here. It's everything on the outside of it. It's 0.1, 0.45, and 0.15. And that comes out to be 0.85.